Okay, good morning, guys. Or good afternoon, depending on what hour you're in. Obviously, I'm not here in class today. Um, Today, we're going to be doing the last new thing of this school year, actually. And it's really not 100% new. It's actually a combination of everything that we've worked with. So we're in 11.5 now. And up here at the top of your notes, it has some examples of the fundamental accounting principle, permutations, combinations, and probability. And we're kind of mixing up those things now. And we're going to talk about how that ends up working out. So on example number 1, which is on the front and the back of this, part A is on the front, part B is on the back, it says the school is having guest speakers come in to speak to each classroom. 5 different speakers are coming in on 5 different days, Monday through Friday. Speakers include Superman, Batman, Thor, Iron Man, and Spider-Man. So our first question says, what is the probability that Iron Man will speak on Monday and Spider-Man will speak on Friday? So there is a specific order. It doesn't matter who speaks in what order. So the very first part that we're going to be dealing with here is permutations. And when we're talking about permutations, where we're using all of our objects, so remember we don't have to use that formula that we used before because we're using every single one of our speakers here. We just need to figure out how many different options we have on each day. Now we know that Iron Man is going to speak on Monday and Spider-Man will speak on Friday. So this is going to be Monday, Tuesday, Wednesday, Thursday, and then Friday. So, but we already know in Monday, I probably should have written this a little bit bigger, but Monday we'll have Iron Man. So this is Iron Man here. And we know on Friday, I guess I actually should have written that above. Iron Man's here. And on Friday, we have Spider-Man. So in each of these boxes, we need to write out how many possibilities we have in those. So Monday and Friday are easy because we have set people that are going to be there. So each of those days only has, excuse me, each of these days only has 1. So I'm going to write 1 over Iron Man that I wrote in this box. So we have 1 in each of those spots. Now for Tuesday, the options we have left, we already have Spider-Man, Iron Man spoken for. So it could be Superman, Batman, or Thor. We don't know which one it's going to be. So there are 3 possibilities. Now, after Tuesday, going into Wednesday, again, we still have spoken for Spider-Man, Iron Man, and one of these 3 has now gone on Tuesday. So that means there's only going to be 2 options left there, and on Thursday that leaves behind 1 possible option. Now, this is working with the fundamental accounting principle, where we're going to now multiply these out. So 1 times 3 times 2 times 1 times 1. Really, the only thing that matters is this 3 times 2. So our total number of permutations is 6 permutations. So there are 6 different possibilities with Iron Man speaking Monday and Spider-Man speaking on Friday. Now, it doesn't ask us how many different ways we can do that. It asks us what the probability of that happening is. So we know that there are 6 possible ways Iron Man and Spider-Man could speak on Monday and then Friday, respectively. So what we need to do is we need to do that permutation side. So we know, or the probability side. So the first thing we need to know is we need to know how many total permutations are possible. So that's where we go back. We want to look at no limitations, how many permutations are possible. So again, going back to our boxes, so this is going to be our total that we're looking at. So again, still looking at Monday, Tuesday, Wednesday, Thursday, and Friday. But now we don't have set things for Monday and Friday. So we're going to start out with 5 possibilities for Monday, 4 on Tuesday, 3 on Wednesday, 2 on Thursday, 1 on Friday. If we multiply all of those out together, they will end up becoming 120 total permutations. Now, 6 permutations yield what we were wanting to look for with Iron Man first and Spider-Man last. There's 120 total permutations. So if we're looking at our probability, we're looking at 6 over 120. Or if we simplify that down, 1 in 20 is the probability. Which, if you want to consider this a percentage or a decimal, it'd be 0.05, or a percentage, it would be 5%. Any of these options is viable. Although 6 to 120, you really need to simplify that down to 1 over 20. Okay, so that's the first example we have. We got one more here, so this video is going to be a little bit longer. And the second option says, what is the probability that Iron Man will speak on Tuesday and Superman won't speak on Friday? So, looking at this one, it's a little bit different. Because we know that Superman won't speak on Friday, and we know that Iron Man will speak on Tuesday. So I'm going to draw out my boxes again. Still Monday, Tuesday, Wednesday, Thursday, and Friday. Now we have a couple things that are set. On Tuesday, Iron Man is speaking. So there's one option there. And then on Friday, it's not Superman. So, since it's not Superman, it means it either has to be Batman, Thor, or Spider-Man. Wow, can't spell Spider-Man. Spider-Man. Which means we have 3 possible options here. Now, since we know that these 2 days are going to be spoken for, so there's going to be one here and one here, that means on Monday, we have 3 that are unspoken for. Now this looks weird because we have 3 in 2 spots, but the reason this is also 3 is because Iron Man has to be here, so that brings this option down to 4. And then we know one of these 3 is going to be speaking here, so that brings the options for Monday down to 3. Now on Wednesday, we're going to drop again from the 3 to 2. And then on Thursday, there's only going to be 1 speaker left for that day. So, using that fundamental accounting principle, multiply this out. It's going to be 3 times 2 times 3. So that's going to give us 18 permutations possible there. We know it's out of 120 possible permutations because we found that on the previous. So our probability for this is going to be 18 over 120. Which, if we simplify this down, you can make it 3 over 20. As a decimal, it would be 0.15, and as a percentage, it would be 15%. So again, these 3 answers, any of those would be correct. If you have any questions, I am going to be out of town until Friday, but you are welcome to try to send me something on Loop Mail. I should be able to respond, hopefully. Otherwise, you can ask me on Friday.